All right, so in our fourth and final lesson in this unit, we're going to be talking about experimental design. So we spent our last two lessons really talking about random sampling and how that helps us with inferential studies. Well, we want to talk about, today we're going to switch gears and talk about our experimental studies. And so experimental studies, remember, those are experimental design is when we have two control groups, or we have two groups. One would be a control group and one would be a group that actually gets some type of treatment. And then we would look specifically at the results of those two different groups. This is nice because we can, if we have a designed experiment, we can actually say that something caused something else to happen. And that it's more than just a correlation, but more of a causation. And so that's what we're going to get into in this lesson. We're going to learn about all kinds of things, designed experiment, controls and treatments, randomization, replication, and then we're going to talk about treatments on a control group and response variable. A lot of vocabulary in here, so you're going to want to make sure that you have your notes ready for what we're going to be doing here. So let's start by taking a look at this slide. Inferential studies use probability sampling techniques so that the sample represents the population without bias. That's what we have. That's where we have been. Well, we're going to move more towards a designed experiment in today's lesson. So we're going to use principles to help establish causation. And that's the big thing here. When we have a designed experiment, we can actually establish some kind of causation. One thing is causing something else to happen. So these principles are the principles that we're going to talk specifically about are control, randomization, and replication. So the controls are the treatments that we use. The randomization are the fact that we would randomly pick who's in, in a control group and who's in the experimental group. And then we have replication, which means the number of people in an experiment. We don't want to have like 4 in each group. We want to have a big number in each group so that we can actually see that there is a difference. And the more people we have in our groups, the more of a difference that we can actually see on whether or not the treatment is being effective or not. So experimental units are the subjects. Subjects if they're human. So in a designed experiment, the individuals or items in which the experiment is being performed, those are called experimental units. So if we're using lab mice, we would call them experimental units. But a lot of times we use human subjects, human people in our experiment, and then they're called subjects. This was an example. An example of this is when we did the folic acid and birth defects. If you remember the study, the doctors had 4,753 women prior to conception, so they were pregnant at the time, and they divided them into randomly groups, 2 random groups. One group took a daily multivitamins of 8 milligrams of folic acid, whereas the other group received only a trace elements, and I think they said it was salt in water, dissolved in water. And so in the language of the experimental design, each woman in the folic acid study is an experimental unit, but because they're a human, we would call them a subject. So the following principles of experimental design enable a researcher to conclude that differences in the results of an experimental study are reasonable enough to attribute to a causation. And so things that can establish causation, with the first one of them would be control. And so a control is where you have 2 or more treatments so that you can compare those two or more treatments when you are finished with your study. Then there's randomization. Randomization is when you have the 2 different groups. You want to randomly select certain women to be in one group, certain women to be in another group. You want to do it randomly. You don't want to have certain from one side of the women from one side of the country and then women from another side of the country, because it could be something within that non-random selection that's causing the difference and not the thing that you're trying to control. And then replication. You want to make sure that you have a sufficient number, okay, a big enough sample of subjects so that when you when you complete your study, you can actually look and detect any differences within that group, and the more people you have in your study, the more replication that you have, the more you can make conclusions about how a certain drug or a certain control affects the population that you're looking to affect. All right, so let's look more closely at the folic acid experiment. The control that the doctors compared the rate of major birth defects for women who took the folic acid to that of women who took other trace elements. That's the control. So you're controlling the folic acid and the other trace elements. That's the control elements. The randomization is that the women were divided randomly into two groups. Okay, this avoids any type of unintentional selection bias that we might have when we're creating our two groups. And then replication, there was a large number, I think it was 4,753 women were recruited for this study. And you want to have a large number of people in the study because that helps detect any effect due to the folic acid that you're controlling. All right, so one of the most common experimental situations involves a specified treatment and a placebo. A placebo is something that might look like a drug, but it's really not. It might be sugar water, or it might be salt in water. So you have a specific treatment, and in this experiment, the treatment was folic acid. The placebo group was a group of women who were pregnant, who just maybe got salt water or some other type of treatment that didn't have any effect on their pregnancy. And so both are treatments. Okay, even the placebo is considered a treatment, but we would define the two groups as a treatment group, those who got the folic acid, and the control group, those who really weren't affected by anything that they were given in the study. All right, so just different things for us to think about when we're in a designed experiment. A response variable, okay, the response variable is the characteristic that we're looking for. In this particular example that we've been talking about is birth defects. So the response variable would be, did we cut down on the number of birth defects of the babies? The factor would be the variable whose effect on the response variable is of interest in the experiment. So we're specifically looking, does folic acid cause birth defects to decrease? And so the factor would be folic acid. The levels would be, now this particular example that we just did only had one level. It was 0.8 milligrams of folic acid. But sometimes studies have different levels. You can double the dosage, and would that cut down on birth defects even more? So there's different levels of the factor that's causing the response, okay, or the birth defects. And then the treatment would be each experimental condition. There's only really one treatment in the example that we use, and that's, did you get the folic acid or not? But you could have, that's called a single factor experiment or a one factor experiment. Sometimes if you have different levels, you can have 3 different types of experiments. Somebody who got no folic acid, somebody who got 0.8 milligrams of folic acid, and then maybe somebody who got 1.6 milligrams of folic acid. And that would be different levels of the treatment for that experiment. All right, so let's take a look at a different experiment and talk about a situation where levels do come into play. So there's a golden torch cacti. The golden torch cacti is a cactus from native Argentina. It has excellent landscape potential. Okay, so we had these 2 researchers at the Boyce Thompson Southwestern Arboretum investigated the optimal method for producing these cacti. These researchers examined, among other things, the effects of a hydrophilic polymer and irrigation regimen on their weight gain, so how big they would get. The hydrophilic polymers are used as soil additives to keep moisture in the root zone. For this study, the researchers chose broadleaf I can't really pronounce that, we're just going to call it P4. The the hydrophilic polymer was either used or not used, and the 5 irrigation regimens were either none, light, medium, heavy, or very heavy. And so, let me get back to this, or very heavy. And so, so those are the different levels of the irrigation. So we have 2 different things going on, and we have different levels in each one. Let's take a look at these 5 things. We're going to look and see if we can identify the experimental units, the response variable, the factors, the levels of each factor, and the treatments. So the experimental units are the cacti used in the study. Okay, that would be like the women in the folic acid study. Okay, although they would be called subjects. Here, because they're cacti, they're cactuses, we would call them experimental units. The response variable is what we're looking for within the experimental units. And what we're looking for is a particular type of weight gain. Okay, did they gain weight or did they not gain weight? And that's the response variable. The factor would be really 2 things, the hydrophilic polymer and the irrigation regimen. So the hydrophilic polymer has 2 levels, okay, either they were used or it was not used, and the irrigation regime or regiment would be either none, light, medium, heavy, or very heavy. Okay, so those are the levels of each factor. So then each treatment, we don't really have like either they were treated or they weren't treated. We have levels of the treatment. And there's actually 10 different levels. And these 10 levels can be outlined using this. We have some of the cactus received no P4 and some received some P4. And then we have the different irrigation. So either none, light, medium, heavy, or extremely heavy. And so there's 10 different treatments. And so here's what we would look to do. Once we have chosen the treatments, we want to decide on how the experimental units are to be assigned to the treatments. So the women in the folic acid study were randomly divided into 2 groups because there were only 2 treatments. One received the folic acid and the other received the trace elements of something else called the placebo. So in this case, if let's say we have 40 cacti, we're going to divide them randomly into 10 different groups of 4 cacti in each group. Okay, so we would have 4 cacti in the first group where there was no water and no irrigation, and see how those cacti compare to cacti in all the other different treatment groups. All right, so that's an example of a random design. So there's also a random block design where there might be something else that we're looking at within the cactus that might play a role in how much they gain weight. And to understand the random block design, let's take a look at a different study. So let's suppose we were going to do a study on specific golf balls and how a certain golf ball might affect the driving distance of when a golfer hits it. So suppose we compare driving distances for 5 different brands of golf balls, okay, and we have 40 golfers, and we want to have a completely randomized design, but then we're also going to talk about a block design. And the block design is going to come into play because we might have, of our 40 golfers, there might be female golfers and male golfers. And maybe for male golfers, it has a bigger effect than on female golfers or vice versa. And so we might want to separate how it is affected, how are certain brands affected by whether the golfers are female or male. So here the experimental units are the golfers. Okay, that's who we're doing the experiment on. The response variable is the distance that they're driving. That's what we're looking to affect. That's the response variable. The factor, okay, the factor is what is being studied, and that's the brand of the golf balls. Okay, and there really aren't any levels of the golf balls. It's just whether they're using maybe a Nike golf ball or a top flight golf ball or something else. Those are the 5 brands. For a completely randomized design, we would just randomly divide all 40 golfers into 5 groups, maybe 8 golfers in each group, and then randomly assign each group to drive a different brand of ball. Okay, so that would be illustrated here. We have all 40 golfers. We send 8 over here, 8 over here, 8 over here, and we have 5 different groups, and then using 5 different brands, and then we compare the driving distances. So that would be different than if we had, if we wanted to also see how it was affected by gender. So if we were doing this same experiment, but we wanted to see how it affected each gender, we would take 20 of the women golfers and 20 men golfers. Okay, and let's just take a look at this experiment. Before we just divided the golfers into 8 or 5 random groups, 4 or 8 people in each group. Well, now we're going to take 20 men and 20 women. We're going to take the men and divide them into 5 groups. We're going to take the women and divide them into 5 groups and give them the different brands and see if there's a difference between how the men and the women using different brands of golf balls, how the length of their drive was affected. And so that's an example of a random block design. And so by blocking, we can isolate and remove the variation in driving distances between men and women, and therefore make it easier to detect any differences in driving distances among the 5 brands of golf balls and be more specific and see how it would affect men as opposed to women. So that's an example of a block design. All of these things are going to be in our homework assignment for tonight. And so for tonight, we would just want to take a look at the problems in Math Excel, and then we'll go over these things tomorrow in class. Good luck, everybody.